kindly take their seats. Our hall and crowd management volunteers are present to assist you. Please follow their guidance to ensure smooth seating arrangements. We request that the participating students and the teachers to take seats from the third row onwards, as the first two rows are reserved. The director, the chief guest, and the guest of honor will be arriving shortly. In anticipation of their arrival, we request you to maintain decorum inside the auditorium and switch your mobile phones to silent mode. I repeat, please take seats from third row onwards. The first two rows are reserved. Okay, we will now screen the Institute documentary, which offers an insightful glimpse into the academic vision, research excellence, and outreach initiatives of IISER Kolkata. Let us watch it together.
Established in 2006, the Indian Institute of Science, Education and Research Kolkata, or IISER Kolkata, the first among IISERs, is a premier institution dedicated to nurturing scientific talent. Nestled on a sprawling 201-acre verdant campus in Mohanpur, near the cultural heart of India, Kolkata, the institute offers a serene environment conducive to academic pursuits. IISER Kolkata's core philosophy revolves around seamlessly blending teaching and research. This unique approach empowers students to not only acquire knowledge but also to actively contribute to the frontiers of science.
I am proud to say that the current year, IISER is ranking 6th in the top 10 science research institution in the country. For the information, we run integrated BSMS program, Master's program, integrated PhD program, and PhD program in basic science disciplines with multiple exits as per the National Education Policy.
Our institute is committed to nurturing the next generation of scientific leaders through a dynamic and interdisciplinary curriculum. In alignment with National Education Policy 2020, we offer credit-based course choice, and this offers flexibility and encourages students to explore diverse fields, ranging from foundational sciences to cutting-edge research.
IISER Kolkata has central facility that contains high-end instrument and excellent infrastructure for research, and that caters the need of researchers, startups, and industries by providing them the round-the-clock access with minimal downtime.
The access and sharing of scientific equipment and infrastructure towards an Atmanirbhar Bharat is to facilitate the creation of knowledge from R&D and applied science towards a developed India. ISAR Kolkata's facilities are such as atomic force microscopy, confocal microscopy, field emission scanning, electron microscopy, stimulated emission depletion microscopy, transmission electron microscope, isothermal titration calorimeter, single crystal X-ray diffractometer, nuclear magnetic resonance, X-ray photoelectron spectroscopy.
Within a decade, the Institute has garnered significant national and international recognition, securing substantial research grants from various funding agencies. This support fuels a vibrant research culture.
Currently, ISAR Kolkata is involved in executing around 200 external projects, including 170 projects from government funding agencies, 16 projects from bilateral funding agencies, and 8 projects from industry, with a total current amount of almost 100 crores.
At ISAR Kolkata, our research initiatives are strategically aligned with national missions, focusing on critical areas such as carbon capture and sustainable energy, also space science innovations and advanced drug development.
IISER Kolkata is a vibrant residential community of students housed in modern hostels. The Institute's state-of-the-art research block and cutting-edge laboratories provide an ideal environment for academic pursuits. Complementing the scholarly atmosphere, the Student Activity Center fosters a dynamic campus life with various sporting activities.
We also complemented by having a lot of cultural and sports activities so that their creativity is surged even after classes and labs and all that, right? So for that, we have like 30 clubs. We have the Students' Affairs Council or SAC, which is actually formed by the students themselves.
And we essentially help to manage and regulate student activities in our institute, and also be the voice of the students to the faculty and other relevant people in our institute.
Our educational institution is committed to the well-being of its students, offering a robust support system that includes comprehensive mental health and counseling services. In addition to mental health services, the institution also houses a fully equipped medical center staffed by qualified healthcare professionals. IISER Kolkata faculty members are renowned for their exceptional teaching abilities and unwavering commitment towards research.
The availability of a small animal research facility at ISAR Kolkata is critical to addressing basic biological and biomedical questions in disease biology, as experiments on humans is often not possible. Small mammalian models such as mice and rats are physiologically closer to humans and therefore amenable to large number of experimental interventions.
In addition, ISAR Kolkata has set up a top-end high-performance computing clusters named Dirac Supercomputing Facility. All the facilities at ISAR Kolkata can be utilized by any user or organization on the payment of nominal charges.
Early research support has been instrumental in cultivating a culture of excellence, as evidenced by the faculty's impressive publication records of approximately 2,400 papers in high-impact journals over the past decade.
The best award for the faculties in recognition of their performances in research in this country is known to be the Bhatnagar Award, given by the Council of Scientific and Industrial Research. Professor Soumitra Banerjee, Professor Bishwarup Mukhopadhyay, Professor Shadhin Kumar Mandal, and Professor Rahul Banerjee are the recipient of this award.
IISER Kolkata fosters a vibrant ecosystem for innovation and startups, creating a dynamic environment where ideas can flourish and turn into successful ventures. Through a dedicated incubation center, the RISE Foundation, supported by the DST Government of India, mentorship programs and access to industry networks, we empower aspiring entrepreneurs to bring their innovative ideas to life.
If you see where our verticals are, we are looking at agri-tech, affordable healthcare and biotech, quantum computing, clean tech, climate change. You talk about any of the deep science verticals, and we are trying to help companies, translate these into great technology.
IISER Kolkata students are actively involved in organizing a diverse range of events beyond athletics. The Institute's literary festival, Lexis, has gained significant popularity.
We are entering into the phase B. We are also proposing BSMS in data sciences, which we all understand is going to make a big difference in everybody's life. Overall, I feel that we have achieved the targets, and to me, our future looks bright.
IISER Kolkata envisions a future where it leads in promoting fundamental scientific education, conducting cutting-edge interdisciplinary research, and translating research outcomes into industrial applications through a robust, innovative ecosystem.
I hope you all liked it. I repeat, please take the seats from the third row onwards because the first two rows are reserved. And I request to maintain decorum inside the auditorium and switch your mobile phones to silent mode. On behalf of IISER Kolkata, I extend a warm welcome to all our participating students, teachers, and guests. We're all delighted to have you today with us. Our hall and crowd management volunteers are present to assist you. Please follow their guidance to ensure smooth seating arrangements. We request the participating students to take the seats from the third row onwards, and the first two rows are reserved. We're waiting for our chief guest to arrive. I request all of you to switch your phones to the silent mode.
কোথায় আছে, দিকে আছে নাকি এক্সটেনশন আছে? ঠিক আছে, এখন ওটাই উপায় একমাত্র। আপনার ভিডিও এনপিটিএল দেখেছি। না কপি করে একটা দুটো মুভি আছে দেখছেন, অন্য জায়গায় দুটো মুভি নিতে হবে। ওটাকে অ্যাকসেপ্ট করতে হবে। ঠিক আছে, ঠিক আছে, হ্যাঁ ঠিক আছে, পাওয়ার পয়েন্টটা তো খুলছে, ব্যাস তারপরে দেখা যাবে। এটা চলছে না কেন?
Good morning, everybody. On behalf of ISER Kolkata, I warmly welcome you all to the celebration of National Science Day 2026. We kindly request you to switch your mobile phones to silent mode. We are deeply honored to inform you that our distinguished chief guest, Professor Shuman Chakraborty, the Director of IIT Kharagpur, our guest of honor, Swami Atunando Priyaji, Pro-Vice Chancellor of Ramakrishna Mission Vivekananda Educational and Research Institute, and our special guest, Padma Shri awardee, Professor Narayan Chakraborty, have arrived. I now request Professor Debashish Kole, Dean of International Research and Outreach, ISER Kolkata, to kindly take over the proceedings. So please.
Good morning, everyone. Thank you, Shiporna. I welcome you all to the celebration of the National Science Day 2026 of ISER Kolkata. Now I request our director, Professor Sunil Kumar Khareji, to come forward for the felicitation ceremony. Sir, please. It's a great pleasure to have with us Professor Suman Chakravarti, the Director of IIT Kharagpur, who is also the chief guest of today's program. May I request him to kindly come on stage. I will now request our director, Professor Sunil Kumar Khareji sir, to felicitate the chief guest, Professor Suman Chakravarti. Thank you, Professor Chakravarti. I will now request Swami Attapriyanandaji Maharaj to kindly come on stage. Swami Attapriyanandaji is a Pro-Vice Chancellor, Ramakrishna Mission, Vivekananda Education and Research Institute, and is the guest of honor of today's program. I will now request our director to kindly felicitate the guest of honor, Swami Attapriyanandaji Maharaj. Thank you, Swamiji. Now I will request our special guest for today's program, Padma Shri awardee, Professor Narayan Chakravarti, to kindly come on stage. I will request our director, Professor Sunil Kumar Khadiji, to kindly felicitate Professor Dr. Chakravarti. Thank you, Professor Chakravarti. May I now request the Director of IISER Kolkata, Professor Sunil Kumar Khadiji, to address the community.
Honorable Chief Guest, Professor Suman Chakravarti, Director IIT Kharagpur, Swami Atma Priyananda ji, we are honored, sir, the guest of honor for this event. Professor Dr. Narayan Chakravarti ji, the Padma Shri awardee from and proud of the nation. My distinguished colleagues, faculty members, students, and staff, very good morning to all of you. And I am overwhelmed to see such a galaxy of people and such a large number of students being present on this day. As you are aware, the National Science Day is celebrated to commemorate the discovery of Raman effect, and this was done at this state itself in 1928 at IACS, and he was awarded in 1928, and he was awarded the Nobel Prize for the discovery, which has long bearing impact till date in form of Raman spectroscopy. He was awarded the Nobel Prize in 1930. So this is the day to tell you that this is the current generation which should be inspired for the science and follow the kind of tradition set up by such luminaries. If you pursue science with passion, many things will come for humanities. I am very proud of being here in this land of science. You see, all 5 Nobel Prize, at least 5 I remember, have come to this state, right from Professor Dr. C.V. Raman, Mother Teresa, Amrita Senji, Gurudev, our Gurudev, and well before that, Professor Ross for malaria, and I think I'm missing one name, probably, Mother Teresa, yeah. So you can understand how productive this state has been for the science. And forget about Nobel Prize as such. This land has produced the luminaries, the great scientists which have brought laurel and proud to the nation, right? So Professor C.V. Raman won, but Professor S.N. Bose, Professor Jagdish Chandra Bose, all sirs, Professor Meghnad Saha, Dr. Asima Chatterjee, to name few, and Acharya P.C. Ray. I think I may forget few, but there are a large number of such people who have made a great contribution to Indian science nationally and globally. Okay, so nothing could be more befitting to have National Science Day here in this state, and I am very privileged and honored to be here because I feel that this is the state, the land where science emerged, where science is growing. And nothing could have been more befitting to have Professor Suman Chakravarti with us, who is Director of IIT Kharagpur, who is going to excite you about the today's science, paradigm of science, and how this passion can be translated into something very significant outcome. We are also very fortunate to have Swami Atipriyananda ji, who is Pro-Chancellor of Ramakrishna Mission University. We are very honored, sir. And the true impact of science should be on the society. And Swamiji is going to share with us how the development of science can transform the society and every one of us. I think he is a renowned scholar for Advaita Vedanta, which says Atman and Brahman is one, actually. Okay, I think it's that much I understand. And then we have Professor Narayan Chakravarti, doyen of science from this state, who discovered many things, and now you will listen from him himself how he conceived some ideas and translated into success, and how you can pursue the science in today's day. So with these words, I would like to tell you that in ISERS, Calcutta, we are actually committed to promote, to give a culture of science to each of the student who is coming here with the eminent faculties we have and state-of-art facilities which we have. Last year, I am happy to share that since the last Science Day, we have launched 2 new programs. One is BSMS in Data Science, and another is Master's Program in Sustainability Science. Sustainability is very important, you all will understand, and so is the data science. So these 2 programs has been launched. In the meantime, since last year, we had numerous faculty accolades. Many of faculty got international and national awards, and our students also brought glory to the institute by winning IGM competition at Germany, and also winning the IICM trophy at ISER Behrampur, among other ISERs. So students are doing great. Most of the students are pursuing science after leaving this place and doing wonderful. I am very happy to put that on record. And then on my personal behalf and on behalf of the institute, I congratulate each one of you, each faculty members, staff, and students, a very happy National Science Day. Please do great in your life. Thank you.
Thank you, Professor Khadiji, for addressing the session. So it gives me now immense pleasure to formally introduce our guest of honor, Swami Atipriyananda Maharaj, who is here with us. So today we have Reverend Swami Atipriyananda with us in this occasion of National Science Day 2026. We are very fortunate. He's a monk of the Ramakrishna order. He's also the founder of Ramakrishna Mission Vivekananda Education Research Institute, a UGC deemed university in Belur Math, Howrah. He was the first Vice Chancellor of Ramakrishna Mission Vivekananda University. He earned his PhD in theoretical physics from the University of Madras, specializing in elementary particle theory. He has several research publications in this area in reputable international journals. He joined the Ramakrishna Order of Monks in 1978, inspired by Ramakrishna Vivekananda's ideology of spiritual liberation, combined with service to humanity in the spirit of worship of God in man. He continues to serve as Pro-Chancellor of Ramakrishna Mission Vivekananda Education and Research Institute, seeking to contribute to its further growth in that capacity. Also, he continues as Secretary of the University Center at Belur. He's also involved as a council member or invited participant in many global organizations working for peace and harmony, interfaith dialogue, and interreligious understanding, comparative mysticism and spirituality, and the holistic welfare of people across the globe. He travels extensively throughout the world to preach and interact with eager spiritual seekers. He is precisely positioned at the cusp of the interface between science and spirituality, and hence is the best choice for this event, as science now has gained confidence of being capable of doing almost anything. But should just anything be done? What should be the direction of the science in this new generation equipped with AI? So let's hear it from Swami Attapriyanandaji Maharaj himself. I request Maharaj to please come on the stage.
Before I begin something serious, just a lighter vein, I always ask the organizers, how long should I speak? He says, now I asked her, oh, you come from far away, please go on. Of course, doesn't mean, you should not take it literally. You should know when to stop. When people begin to yawn and begin to sleep off, there's a time to stop. So I remember an interesting incident which happened long ago. I visited the Vice Chancellor's meet in Bangkok. The inaugurator was the Chancellor of Oxford University, a very learned person naturally and extremely witty. He began by saying the following, which I remember. He said, I went to an international conference and asked the audience, how long should I speak? In one voice there said, sir, please do speak as long as you can, as long as you like, but we are leaving after half an hour. There's a very interesting joke which I remember. So as we normally do, at least we do, we'll begin with the Vedic chant. The moment you chant Sanskrit, people think that something very strange is happening. Nothing strange is happening. These are universal mantras. A mantra is a formula which awakens the innate potentiality in you. Nothing mysterious about it. These are called Shanti mantras. আমি মাঝে মাঝে বাংলাতে বলবো অনেকগুলো ছেলেরা বসে আছে so then I will have the I have to mix English and Bengali. আপনারা সকলেই জানেন pioneer in this was Jagadish Chandra Bose and Satyan Bose. বাংলাতে বিজ্ঞানটাকে কিভাবে নিয়ে গেল ওরা। এই শান্তি মন্ত্রগুলি প্রত্যেকটি উপনিষদের শুরুতে এবং শেষে থাকে, প্রিফিক্সিং অ্যান্ড সাফিক্সিং। উপনিষদের নাম হচ্ছে বেদান্ত, বেদের অন্ত। আর সারমর্ম উপনিষদের হচ্ছে, এইমাত্র বললেন আমাদের ডিরেক্টর, আত্মব্রহ্ম ঐক্যবাদ বলে শঙ্করাচার্য বলছেন। সাধারণত দেখলে উপনিষদটা হচ্ছে মানুষের মধ্যে যে সম্ভাবনা আছে ওটা জাগিয়ে তোলা। This is a word coined by Swami Ranganathanandaji, rather than call it spirituality, etc. The science of infinite possibilities, that's the language which he used, secular kind of language. প্রত্যেকের মধ্যে কিন্তু অনন্ত সম্ভাবনা লুপ্ত হয়ে আছে, লুকিয়ে আছে। আমরা সেই সম্ভাবনাকে জাগিয়ে তোলা, তার জন্য একটি বিশেষ প্রক্রিয়া রয়েছে, সেটাকে উপনিষদ কিন্তু আমাদের দেখিয়ে দিচ্ছে। এর মধ্যে বিখ্যাত একটি উপনিষদ, তার নাম হচ্ছে কঠোপনিষদ। স্বামী বিবেকানন্দের খুবই প্রিয় ছিল ওটা। The very favorite of Swami Vivekananda, particularly because there is a small boy, less than teenage, his name was Nachiketa. Very interesting story. ওর বাবা এটা যজ্ঞ করছিলেন। সেই যজ্ঞের শর্ত ছিল যা যা ছিল সব সম্পত্তি, সব ওনার বিলঙ্গিংসগুলো দান করতে হবে। আমরা সকলেই দান করতে শুরু করি, দেওয়ার সময় খানিকটা একটু কষ্ট হয়। আপনি নেবেন? আচ্ছা 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 দিচ্ছি আমি। তখন দিতে খুব কষ্ট হয় মানুষের, নিতে কিন্তু খুব ভালো লাগে। জীবনে যে সবসময় দিতে চায় এবং নিতে কম চায়, সে মহান হয়। খুব সহজ ফর্মুলা। স্বামীজি বিবেকানন্দ একবার বলেছিলেন, প্রকৃতি কিন্তু তোমার কাছে কেড়ে নেবে, কিন্তু যদি আনন্দে দিতে না পারো, দুটো থাপ্পড় দিয়ে তোমার কাছে কেড়ে নেবে। প্রথম থেকে দিয়ে দাও। Nature will put her hands upon your throat and make your fists open. Man wants to hold with clenched fists. মুষ্টিবদ্ধ হাতে আমি দেবো না, দেবো না। নেচার এটা দুটো থাপ্পড় দিয়ে তোমার কাছে কেড়ে নেবে, নিয়ে আনন্দে দিয়ে দাও। যে যত দিতে পারে, যত কম নিতে পারে, সে মহান হয়। খুব সহজ। আমাদের বাচ্চাদের বিশেষ করে আমি বলছি, অনেকে তোমাদের বুঝাবে, মহারাজ সে বলেছেন তো বোকার মতো এসব করবি না। আমি জানি অনেকে আমাদের, আমি বিদ্যা মন্দিরে ছিলাম, এই খবরদার খুব বুদ্ধিমান হবি, বন্ধুদের কাছে এগুলো শেয়ার করবি না। যত স্বার্থপর হবি ততই কিন্তু মহান হবি। এটা হচ্ছে আমাদের ফর্মুলা। আমি তোমাদের সকলকে বলছি বিবেকানন্দের বাণী। স্বামীজি বললেন, unselfishness is more paying, only people do not have the patience to practice it. নিঃস্বার্থ যত হবে ততই কিন্তু বেশি করে তুমি পাবে, কিন্তু সময় লাগতে পারে। তার বৈজ্ঞানিক ভিত্তিটা হলো একটি খুব ছোট্ট এক্সপেরিমেন্ট, স্কুলে আমরা পড়েছি এটা, দ্য এক্সপেরিমেন্ট অফ ম্যাকডিবার্স হেমিস্ফিয়ার্স। মনে পড়ছে? ছেলেদের বলছি, দুটি অর্ধগোলক হেমিস্ফিয়ার্স আর পুট টুগেদার অ্যান্ড এয়ার উইদিন ইজ পাম্পড আউট। ভিতরে যত বাতাস আছে সবগুলো বার করা হচ্ছে। তখন ভিতরে কি থাকবে? কিছুই থাকবে না। তখন বাইরের বাতাস ভিতরে ঢুকার চেষ্টা করবে, বিকজ নেচার অ্যাবহর্স ভ্যাকিউম। যেখানে কিন্তু শূন্যস্থান তৈরি হবে, তখন বাতাস ঢুকার জন্য অসম্ভব পরিশ্রম করে ঢুকতে চাইবে। তখন কয়েকটি ঘোড়া নিয়ে দুটিকে পৃথক করা যায় না। Several horses cannot also separate these two because a vacuum has been created and the entire atmospheric air is trying to enter into this. What is the lesson you get from this? এখান থেকে আমরা বুঝতে পারি, যত আমরা খালি করব নিজেকে, ততই কিন্তু আমরা পাব। যত শূন্যস্থান তৈরি করবে অন্তরে, ততই কিন্তু পূর্ণ হব। শূন্য এবং পূর্ণ দুটি একই জিনিস। It can be mathematically proved that zero and infinity are the same thing. I will try to do that after some time. So try to empty yourself. Empty the mind to receive the immeasurable. This is the statement of J. Krishnamurti, the great philosopher. যত নিজেকে খালি করবে, খালি করে কি করবে? উজাড় করে দাও, বাংলাতে বলে give, give. Swami Vivekananda said, give help, give love, give all that you have for others, and don't ask anything in return. দাও দাও ফিরে নাহি চাও, থাকে যদি হৃদয়ে সম্বল, অনন্তের তুমি অধিকারী, যে ফিরে চায় তার সিন্ধু বিন্দু হয়ে যান। স্বামীজির কথা এটা, যে কিন্তু ফেরত চাইবে, আমি চাই চাই করে, তার অনন্ত অধিকারী যে বিশাল একটি সিন্ধু রয়েছে অন্তরে, আনন্দের সিন্ধু, জ্ঞানের সিন্ধু, সে বিন্দুর মতন পরিণত হয়ে যাবে। আমরা বিজ্ঞানের কথা যখন বলি, when we talk about science, what are the lessons we can learn from basic scientific principles? Unfortunately, science has been overshadowed by technology. আমি বিশেষ করে আমার ছাত্রছাত্রীদের আমি বলছি বিজ্ঞানে, আমি আর্টসের কথা বলছি না। তার কারণ লোকে মনে করে টেকনোলজি পড়লেই বিশাল চাকরি পেয়ে যাবো, টেকনোলজি পড়লেই বিশাল কিছু হবে, মোটেই না। Science is most fundamental and technology is only built upon science. If we go on pursuing only technology, a day would come there will be nothing original left. All original inventions, discoveries are made through science, and technology's application comes much later. বিশাল বিশাল জীবনে কিন্তু যত চিন্তা হয়েছে সায়েন্সে, টেকনোলজি অনেক পরে এসেছে। So the two-pronged attack, one is pure science, which we call science. There is a technology which is application of science. Which is more important? This is a fundamental question which has not been fully solved yet. There has been debate even among scientists. Which is more important? Swami Vivekananda said both are equally important. And fundamental thinking, মৌলিক চিন্তা করার যে ক্ষমতা যদি মানুষ হারিয়ে ফেলে, তাহলে প্রযুক্তিবিদ্যাও কিন্তু আস্তে আস্তে কিন্তু ক্ষীণ হয়ে শেষ হয়ে যাবে। বর্তমানে আর্টিফিশিয়াল ইন্টেলিজেন্স, এআই বলে যে বস্তুটা, সে মঞ্চের উপরে নাচছে এখন, ইটস ডান্সিং অন দ্য স্টেজ অ্যান্ড এভরিবডি ইজ রানিং বিহাইন্ড এআই এআই করে। সমস্ত হাইপ এগুলো সব আমাদের দেখা হয়ে গেছে। After a couple of years, after a couple of, not decades perhaps, AI কিন্তু কোথায় লুপ্ত হয়ে চলে যাবে, but the fundamental discoveries of science will remain. তার সবচেয়ে বড় উদাহরণ, the greatest example of this, 2022-2025, the Nobel Prizes were awarded for a discovery in quantum mechanics and quantum theory, which is more than 100 years old. 100 বছর আগে যে কোয়ান্টাম থিওরি, তারপরে কোয়ান্টাম মেকানিক্স ইত্যাদি হলো, সেটার গুরুত্ব এখনও রয়েছে। কোয়ান্টাম এনট্যাঙ্গলমেন্ট বলে একটি জিনিস আছে, 2022 সালে 3 জন নোবেল পুরস্কার পেয়েছিলেন। কোয়ান্টাম মেকানিক্যাল টানেলিংয়ের উপরে 2025 সালে পেয়েছিলেন। অর্থাৎ সায়েন্সের যে মৌলিক গুরুত্ব কখনো কিন্তু হারাবে না। টেকনোলজি নতুন নতুন হতে পারে, মোবাইল ফোন সকলের পকেটে আছে নিশ্চয়ই, নতুন নতুন কিন্তু টেকনোলজি আসছে, এটাকে ফেলে দিয়ে নতুন টেকনোলজি যাচ্ছি আমরা। কিন্তু সায়েন্সে কিন্তু আমরা পুরনো থিওরিগুলোতে ফেলতে পারছি না, তাতে কিন্তু নতুনত্ব নিয়ে আসি। We bring newness to that by adding more ideas into it. So my plea on this occasion of the National Science Day is try to think originally and try to think fundamentally. Einstein was asked by somebody, how did you come upon this extraordinary theory of the relativity? আপেক্ষিক বস্তুবাদ যেটা আছে, সেটা কী করে আপনারা কিন্তু আবিষ্কার করলেন? He gave a very simple, interesting answer. You see, when we are children, we ask so many strange questions to our parents, uncomfortable questions. আমরা যখন শৈশবে বাবা মাকে এবং শিক্ষকদের অনেক রকম প্রশ্ন করি, স্যার এটা কেন হলো? The standard answer we get, we also got it, এই চুপ করো তো, আবল তবল প্রশ্ন করে যাচ্ছে, বইতে যাচ্ছে পড়ো ভালো করে, পরীক্ষা এসে গেছে। এনি ফান্ডামেন্টাল কোয়েশ্চেনকে অবল তবল করে দেবে ওরা। শিক্ষকরা বলে, আরে বড় ক্লাসে হলে সব জানতে পারবি, চুপ করে থাক, বড় ক্লাসে এলে বলে ছোট ক্লাসে পড়ো নেই, এখন কেন বলছো? This game goes on till your creativity or originality is killed. Educational institutes বলে যেটা বলছি, সমস্তগুলোকে আমাদের ক্রিয়েটিভিটিকে কীভাবে খর্ব করা যায় তার জন্য বিশাল একটা কল তৈরি করেছি আমরা। মুক্ত চিন্তা যারা করেছে এবং অবল তবল প্রশ্ন করেছে তারাই কিন্তু মহান হয়েছে। Einstein said, I also used to ask some very interesting, uncomfortable questions of my parents, but usually we forget them when we grow. In my case, I did not forget those fundamental questions. I pursued them and said, how is this possible? How does science grow and begin? সায়েন্সের উৎস কোথা থেকে বলো তো? এই ছেলেদের বলছি আমরা, সায়েন্স কোথা থেকে উৎস হলো? সায়েন্স মানে আকাশ থেকে পড়ছে কি না, আমাদের মানুষের মনেই তো আসছে না। সায়েন্স গ্রোজ ইন হিউম্যান মাইন্ড। Where does it come from? It comes from observation of nature. এটা ফান্ডামেন্টাল মনে রাখো। এটা প্রকৃতিকে দর্শন করে প্রকৃতি থেকে আমরা শিক্ষা পাই। এরোপ্লেন কীভাবে এলো? রাইট ব্রাদার্স যখন শুরু করলেন, পরে গেলাম মানুষ কিন্তু উড়তে পারছে না, এই পাখিগুলো উড়ছে কী করে? পাখির দুটি ডানা আছে আর এটা পুচ্ছ আছে, টেল। তাহলে আমাদের দুটি ডানা এবং টেল থাকলে উড়তে পারবো। So this is a lesson they learned and slowly built what is called the aeroplane. So we observe nature and slowly begin to understand some fundamental ideas we get. Nature of light. আমরা চারদিকে লাইট দেখছি তো, আলো বলছি, আলোর গতিবেগ নিয়ে আইনস্টাইনের যা বিখ্যাত আছে, the speed of light in vacuum is a constant, absolute constant of nature. এটা কেন হয়েছে বিশাল ফিলসফি ওর মধ্যে আছে। যত স্পিডে যাচ্ছে তত কিন্তু ওজনটা বাড়তে থাকে। ভেলোসিটি অফ লাইট হলে ওজনটা ইনফিনিট হয়ে যাবে, which is not possible. লাইট নিয়ে যখন আবিষ্কার করার চেষ্টা করলেন স্যার আইজ্যাক নিউটন, ওই বিখ্যাত একজন, ফিজিক্সের কোনো এরিয়া নেই ওখানে হাত দেননি উনি। তখন ফিজিক্সটাই কিন্তু সবচেয়ে বড় ছিল, অনেক রকমের চিন্তা ভাবনা করে, তারপরে কেমিস্ট্রি, বায়োলজি ইত্যাদি হলো। বায়োলজিক্যাল সায়েন্সেস আর অলসো ভেরি ভেরি ইম্পর্ট্যান্ট। প্রাণ নিয়ে আমরা যেটা করে যাচ্ছি, অব্যক্ত বলে একটি সুন্দর বই লিখেছিলেন জগদীশ চন্দ্র বসু, বাংলায় আছে। ছেলে মেয়েদের বলছি, তোমাদের পাঠ্য বই ছাড়া অন্যান্য সায়েন্সের বই পড়ার চেষ্টা করো। পপুলার সায়েন্স ফিকশন তো প্রচুর আছে, জর্জ গ্যামো, অর্থার রেডিংটন, এগুলো আমরা খুব পড়তাম। ফাইনম্যান লেকচার্স ইন ফিজিক্স বলে একটা সিরিজ আছে, অসাধারণ সুন্দর সহজ করে ওটা বলছেন। আনফর্চুনেটলি our students have lost the habit of reading these kind of popular, extremely valuable literature. ওইগুলো আমরা পড়ি না, বইতে যেটা আছে ওটাই পাঠ করে যাচ্ছে। কি সরসভাবে অত্যন্ত গল্প করে বিজ্ঞানকে বুঝিয়েছেন ওনারা। নিউটন বললেন সমস্ত লাইট কার্পাসকুলার নেচার, পার্টিকেল হিসাবে যাচ্ছে, তার রিফ্লেকশন, রিফ্র্যাকশন ইত্যাদি হচ্ছে। আমরা মনে রেখো, আমি ছাত্রদের বিশেষ করে বলছি, সমস্ত এক্সপেরিমেন্ট থেকেই কিন্তু আমরা ব্যাখ্যাটা বার করতে চাইছি। লাইটে দুটি বিখ্যাত, একটা রিফ্লেকশন, প্রতিফলন হচ্ছে, রিফ্র্যাকশন একটা হচ্ছে। কীভাবে হলো? তখন চিন্তা ভাবনা করে বললেন ওই পার্টিকেলস যেটা কার্পাসকেলস আছে ওটা ফিটস অফ রিপালশন অ্যান্ড ফিটস অফ অ্যাট্রাকশন হচ্ছে। এগুলো সত্যি হচ্ছে কিনা জিজ্ঞাসা করে, মানে ব্যাখ্যা দিতে হবে তো। আমরা এক্সপেরিমেন্টালি যেটা দেখছি ব্যাখ্যা দেওয়ার জন্য কিছু থিওরি নিয়ে আসি, ও থিওরি করতে 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 তার বৈজ্ঞানিক ভিত্তিটা নেওয়ার চেষ্টা করি। যদি এক্সপেরিমেন্ট অন্যথা যদি বলে ওটা খানিকটা ওটা পরিবর্তন করে করে বিজ্ঞানটা এগিয়েছে। দ্যাট ইজ দ্য স্টোরি অফ সায়েন্স। পরবর্তীকালে দেখা গেল ইন্টারফারেন্স, ডিফ্র্যাকশন, পোলারাইজেশন ইত্যাদি যখন হলো, তখন বড় ইত্যাদি তো কার্পাসকুলার হতে পারে, লাইটের ওয়েভ, তরঙ্গ হওয়া উচিত। সো দুটি রাইভাল থিওরি, এটা চিন্তা করো সায়েন্স কীভাবে এগিয়েছে। রাইভাল থিওরি মানে এই দিকে তরঙ্গ, ওই দিকে হচ্ছে কর্পাসকুলার অথবা পার্টিকেল। এই দুই রকমই কিন্তু আলোর প্রকৃতি আমরা দেখতে পাচ্ছি, দ্য নেচার অফ লাইট, দুটোই কিন্তু বিরোধ। How science is trying to reconcile the so-called contradictions. This is another important philosophical point. Philosophically, there is nothing called contradiction in nature. আমরা বিরোধ যেটা বলি, আমরা বিরোধ কিন্তু প্রকৃতিতে কোনো বিরোধ নেই। মানুষের মনের মধ্যে বিরোধ যেটা আছে সেটাকে প্রকৃতির উপরে আমরা আরোপ করি। ধর্মেতেও তাই, কোনো বিরোধ নেই কোনো ধর্মে, আমরা বিরোধ তৈরি করে যাচ্ছি। Corpuscular nature of light and the wave nature of light, how to reconcile. করতে করতে কোয়ান্টাম থিওরি যখন এলো 1900-এ ম্যাক্স প্ল্যাঙ্ক, তখন বললেন লাইটটা কিন্তু পার্টিকেল বটে, কিন্তু পার্টিকেল ইজ এন এনার্জি প্যাকেট। চিন্তা করে কীভাবে এনার্জি আইডিয়া ইজ বিং বিল্ট আপ ইন্টু পার্টিকেল। কত এনার্জি? The energy of a packet is proportional to the frequency of the radiation. Frequency is a wavelength related. Inverse. This is a typically wave concept. How the wave concept and the corpuscular concept are being put together. The hybrid concept. So far so good. তখন একজন ভাবলেন, if particle can manifest wave characteristics, quantum, এটা particle না wave, বোঝা যাচ্ছে না, দুটো মিলিয়ে একটা আসছে। So now, if radiation which is light can have particle characteristics, why not particle can have wave characteristics? এটা সূক্ষ্মভাবে চিন্তা করো। এর মধ্যে কি আসছে? Concept of symmetry বলি আমরা। Symmetry is one of the most fundamental concepts of science. সুন্দর চেহারা আমরা বলি না, বাহ দেখতে খুব সুন্দর, মানে কি? সুন্দর মানে কি বলো তো? সিমেট্রি। আমি হাঁটছি, কি আগলি, সুন্দর নয়। কেন? এইদিকে হাতটা আছে, এইদিকে হাতটা সমান সমান নয়। There is an excess of symmetry in the human body. দুটো চোখ, দুটো কান, এগুলো সমস্ত ঠিক ঠিক আছে। একটা কান এখানে আছে, আরেকটা কান এখানে আছে, তাহলে সিমেট্রি হলো না? You call it ugly. The concept of symmetry is related to the concept of beauty. How the various ideas come together. Science is pursuit of truth, আমরা বলি. Arts, humanities, pursuit of beauty. Satyam, Sundaram. Ultimate reality is Satyam, Sundaram, Shivam, which science ignores. It should be beneficial to humanity. Satyam, Shivam, Sundaram. Symmetry is responsible for giving beauty to anything. So one simple person thought, if radiation can exhibit particle characteristics, why not particle exhibit wave characteristics? Symmetry hote have. Same idea, electricity is generated, magnetism is generated when a current carries wire. School physics amra podhechi. A current carrying wire behaves like a magnet. Then ulto dike keno hobe na? If electricity can generate magnetism, magnetism should also generate electricity. So with the change of the magnetic flux, then electricity is induced. Faraday's famous experiment of induction, electromagnetic induction. Kotha theke eschilo? From the concept of symmetry. Keন এটা বলছি তোমাদের? মানুষের মনে symmetry, which is fundamental to nature. Why is symmetry fundamental? Nature has to be beautiful. It's an axiom. প্রকৃতি সবসময় সুন্দরতাকে পছন্দ করে, সৌন্দর্যকে পছন্দ করে, and সুন্দরতা is related to symmetry. It's a huge concept through which so many ideas developed in physics. SU2 symmetry, SU3 symmetry, SUN symmetry, supersymmetric schemes, and the standard model of the particles, etc. কত দূর চলে গেছে কোনো ঠিক নেই, from a simple idea. If particle can have wave characteristics, what should be the wavelength of this wave? Once again, symmetry. ওখান থেকে বার করে একজন সায়েন্টিস্ট, পরবর্তীকালে সায়েন্টিস্ট বলা হলো, ইজ সিম্পল অর্ডিনারি পার্সন, ইজ নেম ইজ ডি ব্রয়লি লেখা হয়, প্রনাউন্সিয়েশন অফ ফ্রেঞ্চ পার্সন। উনি একটা মাত্র পেপার লিখেছেন, সেমিনাল পেপার। আমরা গাদা পেপার বলছি না এখন, কত পেপার আছে, সেই জন্য বড়ো পেপারকে যত কেটে কেটে করবে তত নাম্বার অফ পেপার দেখাতে পারবে। ইটস কল সালামি স্লাইসিং বলে ওটাকে। উনি একটা মাত্র পেপার লিখেছেন, ইট ইজ PhD thesis for which he got the Nobel Prize. It's a very simple idea. সেখান থেকে এলো কোয়ান্টাম থিওরি, সেখান থেকে এলো কোয়ান্টাম মেকানিক্স, সেখান থেকে এলো শ্রোডিঙ্গারস ওয়েভ মেকানিক্স, হাইজেনবার্গস ম্যাট্রিক্স মেকানিক্স। দুজন মিলে রেভলিউশনাইজ করে ছেড়ে দিল হোল অফ ফিজিক্স। তখন এরা ভাবলো ম্যাগনিফিকেশন আমরা লাইট দিয়ে পাচ্ছি, মাইক্রোস্কোপ ইত্যাদি। So instead of light, if suppose you use high-speed electrons, ওরা particle তো, electrons গুলি, electrons are not only particles, they are waves also. এটা কি wave? হ্যাঁ wave তো। এটা কি particle? হ্যাঁ wave particle তো। তাহলে কি ওটা? এডিংটন মজা করে বলছেন, এটা পার্টিকেল কেন wave বোঝা যাচ্ছে না, ওয়েভিকল বলে দিই আমরা। তখন লিখছেন, সোমবার, বুধবার, শুক্রবারে সে পার্টিকেল হয়ে থাকছে, মঙ্গলবার, বৃহস্পতিবার, শনিবারে ওয়েভ হচ্ছে, রবিবারে কিছুই না হয়ে দেখছে শুধু। মজা করে লিখছেন, দ্যাট মিনস হোয়াট ইজ দ্য নেচার অফ রিয়ালিটি। আর একটা প্রশ্ন, তাহলে রিয়ালিটিটা কি? ওটা কি পার্টিকেল, ওটা কি ওয়েভ? এই দুটোই কিছুই বোঝা যাচ্ছে না তো, কিছুই বুঝতে পারছিস না তো। এইটাই বিগিনিং অফ সায়েন্স। আমি কিছু বুঝতে পারছি না যখন জানো, তখনই কিন্তু ডিসকভারি আসবে। হ্যাঁ হ্যাঁ আমি জানি তো, আমি জানি মানে কিছুই জানো না। উপনিষদ বলছেন যে জানে বলে মনে করে সে কিছুই জানে না, সে জানে না বলে জানে সেই জানে। আমি জানি অথচ জানি না, এই বাক্যকে যে ভালো করে জানে সেই জানে। It's a beautiful statement. Socrates in Athens suddenly heard a mysterious voice. Socrates is the wisest man on earth. Socrates সবচেয়ে বেশি বুদ্ধিমান, সব ছুটলো। Socrates congratulations, incorporeal voice, অশরীরী বাণী বলে দিয়েছে, তুমি নাকি wisest man. Socrates বলে, আমাকে বললো? আচ্ছা হ্যাঁ ঠিকই বলেছে। আমি একমাত্র জানি, আমি কিছু জানি না বলে। আমি কিছু জানি না বলে জানা বেশ কঠিন। না না আমি জানি তো। যে কোনো মানুষ বলছে তুমি জানো? হ্যাঁ হ্যাঁ আমি জানি কিছু। কি জানো বলে তো, তা তো জানি না। সায়েন্স শুরু হয় যখন আমি জানি না বলে জানি। সেখান থেকে কত দূর সেগুলো। ইলেকট্রনকে কিন্তু লাইটের পরিবর্তে ব্যবহার করা যায় কিনা, ইলেকট্রন মাইক্রোস্কোপ হলো, সেখান থেকে ম্যাগনিফিকেশন কত দূর চলে গেলে কোনো ঠিক নেই। মেডিকেল অ্যাপ্লিকেশনস ইত্যাদি চলে এলো। অ্যাপ্লিকেশনস কে মাচ লেটার। ডিরাক বলে বিখ্যাত একজন ফিজিসিস্ট ছিলেন। আই এম সরি, আমি ফিজিক্স দিয়ে বেশি বলছি, বিকজ দিস মাই ট্রেনিং। বায়োসায়েন্সে ইকুয়ালি কিন্তু ফ্যান্টাস্টিক থিওরিজ আছে। প্লাস অর মাইনাস একটা এসেছিল এটা ইকুয়েশনে। দেখুন সাধারণত আমাদের বলা হয়, আমরাও ছোটোবেলা শিখেছি, ইগনোরিং দ্য নেগেটিভ মাইনাস, ওয়াই শুড ইউ ইগনোর? ডিরাক বললে ইগনোর করতে যাবো কেন? ম্যাথমেটিক্যালি প্লাস অর মাইনাস যখন আসে, মাইনাসটাও নিলে কেমন হয়? সেখান থেকে এমন একটা রেভলিউশন থিওরি বার করলেন উনি, দ্য সি অফ নেগেটিভ এনার্জি ইলেকট্রনস। ইম্যাজিনেশন কেন বলছি? বিজ্ঞানে কিন্তু প্রচণ্ড ইম্যাজিনেশন লাগে। বিজ্ঞানে সবচেয়ে বেশি লাগে রবীন্দ্রনাথ, সবচেয়ে বেশি আগে কালিদাস, সবচেয়ে বেশি লাগে তোমাদের সাহিত্য। তখন থেকেই কিন্তু বিজ্ঞানের এগুলো আসবে। সি অফ নেগেটিভ এনার্জি ইলেকট্রনস কেউ দেখে নেই, কিন্তু দেখে কোনটা? ওখান থেকেই একটি ইলেকট্রন জাম্প করে যখন পজিটিভ স্টেটে চলে যায়, ওখানে একটা গর্ত তৈরি হয়, ওই গর্তটা হচ্ছে পজিট্রন। নেগেটিভ ইলেকট্রন যখন জানে পজিটিভ ইলেকট্রন, তখন কিছুই কেউ জানতো না, বলতেন পাগল বললো। যত পাগল বলবে তোমাকে ততই ভালো সায়েন্স জানবে তুমি। সায়েন্টিস্টরা তো পেকুলিয়ার বিভিন্ন রকমের বিচিত্র বার করলো। 25 বছর বাদে কসমিক রেসের মধ্যে অ্যান্ডারসন ডিসকভার করলেন পজিট্রন বলে সত্যি একটা বস্তু আছে। এখন পজিট্রন এদিকে গেল পজিটিভ ইলেকট্রন, ওইদিকে গেল নেগেটিভ ইলেকট্রন। এখন নেগেটিভ পজিটিভ একসঙ্গে এলে কী হবে? এটা এনার্জি তৈরি হবে। এনার্জি মানে ওটাকে ফোটন বলা হয়। ফোটন ইজ এ পার্টিকেল, জানেন তো? ফোটন ইজ এ পার্টিকেল, অথচ ফোটন হচ্ছে এনার্জি। ফোটনের স্পিন আছে বলছে, ইন্ট্রিনসিক স্পিন অফ এ পার্টিকেল আর একটা বিচিত্র। জিরো স্পিন পার্টিকেল বলে, স্পিনই যদি না থাকে জিরো স্পিন আবার কি? এইগুলো হচ্ছে বিচিত্র বিচিত্র যে ধারণা, from where followed extraordinarily beautiful actual experiments which have benefited humanity beyond comparison. অসাধারণ ওখান থেকে অ্যাপ্লিকেশনটা বেরিয়েছিল। তখন পজিটিভ অ্যান্ড নেগেটিভ ইলেকট্রনস, পজিট্রন অ্যান্ড ইলেকট্রন একসঙ্গে এলো, a quantum of energy is produced. তখন হচ্ছে সিমেট্রি, ইলেকট্রন পজিটিভ একসঙ্গে এসে যদি এনার্জি তৈরি হয়, তাহলে এনার্জি থেকে ইলেকট্রন পজিটিভ আসতে পারবে না কেন? Then they found it as possible. তার মানে গভীরভাবে চিন্তা করো, ছাত্রদের বিশেষ করে আমি বলছি, এটা এনার্জি থেকে তুমি দুটো পার্টিকেল তৈরি করতে পারছো। দ্যাট মিনস এনার্জি ক্যান বি মেটেরিয়ালাইজড ইন্টু পার্টিকেলস। তুমি এনার্জি আছে, এনার্জি মানে যে শক্তি বলবো নাকি, এই শক্তি থেকে তুমি ম্যাটার তৈরি করতে পারছো। এটা যদি মাইক্রো লেভেলে যদি হয়, ম্যাক্রো লেভেলে কেন হবে না? সেজন্য আমাদের বলছে হিন্দু ধর্মে এই সমস্ত সৃষ্টি করলেনটা কে? একজন মহাশক্তি। এই মহাশক্তির নাম কালী হতে পারে, দুর্গা হতে পারে। তিনি হচ্ছেন শক্তি। শক্তি ছাড়া কোনো সৃষ্টি হতে পারে না। আমরা ছোটোবেলা থেকে জানি, গান করি, শক্তি স্বরূপা ইত্যাদি দুর্গাপূজার সময়। কিন্তু গভীর বৈজ্ঞানিক তত্ত্ব আছে, শক্তি কিন্তু সৃষ্টিটা করতে পারে। ইলেকট্রন পজিট্রন পেয়ার ক্যান বি ক্রিয়েটেড বাই দ্য মেটেরিয়ালাইজেশন অফ আ কোয়ান্টাম অফ এনার্জি। সেখান থেকে কত রকমের অ্যাপ্লিকেশনটা এসছে। অ্যাপ্লিকেশনটা অনেক পরে আসে। অ্যাপ্লিকেশন যারা করে তারা বিজ্ঞানের ভিত্তিতেই করে এবং মানুষের কল্যাণের জন্য ওটা ব্যবহার করা উচিত। নিউক্লিয়ার এনার্জি যখন হলো, এনার্জি সব ঠিক আছে, আইনস্টাইনের বিখ্যাত ইকুয়েশন বারবার বলি আমরা, E=mc² ইত্যাদি। আইনস্টাইনের যে চিন্তাধারা কিন্তু সাংঘাতিক একটা ছিল, অরিজিনাল, নতুন করে কিছু করেননি উনি, সব আগে থেকে ছিল। লরেন্স ট্রান্সফরমেশন ছিল, ফিজুরাল কন্ট্রাকশন ছিল, মিনকাউস্কি স্পেস ছিল, সমস্ত নিয়ে কি করে রান্না করতে শিখতে হবে। বিজ্ঞানের যত তোমাদের ধারণা আছে, যখন মশলাগুলো রয়েছে তোমার কাছে, মশলা আলাদা আলাদা, মশলা তো কেউ খেতে পারে না, মশলা দিয়ে কি করে তুমি ভালো করে রাঁধতে পারো। সায়েন্টিস্ট, অরিজিনাল সায়েন্টিস্ট ইজ এ পার্সন হু ক্যান কুক ওয়েল। ঠাকুর শ্রীরামকৃষ্ণ কী করলেন, স্বামী বিবেকানন্দ কী করলেন, ধর্মজগতে, আধ্যাত্মিক জগতে যেটা ছিল সবগুলো একসঙ্গে এসে সুন্দর একটা রান্না করে আমাদের পরিবেশন করলেন। So Einstein also, original ideas he threw, from there he created an equation, he derived an equation E=mc². That means matter can be smashed to produce energy and vice versa. সেখান থেকে নিউক্লিয়ার এনার্জি এলো, and unfortunately it is used to destroy humanity. সেখানে কিন্তু বিজ্ঞান বলছে আমি কিন্তু অ্যামরাল। অ্যামরাল মানে ইমরালও না, মরালও না, নৈতিকতা কিছু আছে বিজ্ঞানের। বিজ্ঞান বলছে আই হ্যাভ নো অ্যাকাউন্টেবিলিটি, আমি বলে দিলাম তুমি নষ্ট করো, খাও, যা খুশি করো। সেখানে বর্তমানে বারংবার বলা আছে সায়েন্টিস্ট হ্যাভ আ মরাল রেসপন্সিবিলিটি টু সোসাইটি। বিখ্যাত বিখ্যাত সায়েন্টিস্ট লাইক আইনস্টাইন ওরা ওয়ার্ল্ড ওয়ারের সময়, বিশ্বযুদ্ধের মধ্যে বিশাল আন্দোলন চালালেন, মানুষের শান্তি চাই। যখন নিউক্লিয়ার এনার্জি ব্যবহার করা হলো মানুষকে মারার জন্য, ডিস্ট্রয় করার জন্য, ওপেনহাইমার খুবই দুঃখিত হয়েছিলেন। আমি এটা ডিসকভারি করলাম, মানুষ কিন্তু মারার জন্য নয় এটা। সেখানে হিউম্যান বিইং কামস টু এক্সিস্টেন্স। একটা জিনিস বলে শেষ করছি আমি, বিজ্ঞান প্রযুক্তি যত আমরা বলি না কেন, সমস্তগুলো মানুষকে কেন্দ্র করে। whether you call it science, whether you call it religion, whether you call it technology, everything is centered around a human being. That human being should be really humane, সত্যি সত্যি মানুষের মতন মানুষ। এটা বাংলাতে একটা অদ্ভুত শব্দ, এটা আশীর্বাদ করুন যাতে আমি মানুষের মতন মানুষ হতে পারি। আমরা লিখি, আমার ছাত্র একজন বাংলাতে ইমেল পাঠায়, সঙ্গে সঙ্গে গুগল ট্রান্সলেট করে দেয়, আশীর্বাদ করুন মানুষের মতন আমি মানুষ হতে পারি। ট্রান্সলেট করেছে, প্লিজ ব্লেস মি দ্যাট আই বিকাম এ হিউম্যান বিইং লাইক এ হিউম্যান বিইং। এটা বাংলাতেই আছে, এই ধরনের এক্সপ্রেশন কোথাও থাকে না। অর্থাৎ আমি যেন পশুর মতন অথবা অচেতন পদার্থের মতন মানুষ যেন না হয়। So human being has to use the science for the good of humanity. And there are so many things in the universe which are beyond science. এক্সাম্পল বলে শেষ করছি আমি। বিজ্ঞান শেষ কথা কখনো মনে করবেন না। বিজ্ঞান আসে একটা স্তর থেকে, মানুষের স্তর থেকে, সে ইনটিউশন বলি আমরা, সংস্কৃতে বাংলাতে বলি মেধা প্রজ্ঞা ধী, ধিয়ো ইয়ো ন প্রচোদয়াৎ, গায়ত্রী মন্ত্র। একজন শিষ্য যখন যায় ওকে বলা হয় গায়ত্রী মন্ত্র কেন, ভিতরে যে ধী যেটা আছে যেন তার উন্মেষ যেন হয়, অওয়েকেনিং অফ দ্য ধী, উইচ ইজ ইনটিউশন। Only through intuition scientific discoveries are possible. After that, the logical mind comes and arranges. Huge debate when the artificial intelligence first came out by Roger Penrose and his opponents. He wrote a book called The Emperor's New Mind. Artificial intelligence bolchen, মানুষের মস্তিষ্ক, human brain also thinks algorithmically. মানুষের মস্তিষ্ক অ্যালগরিথমিক্যালি কাজ করছে কি করছে না, এটা নিয়ে বিশাল ডিবেট। মানুষের মস্তিষ্ক অনেক সময় করতে পারে অ্যালগরিথমিক চিন্তা, লজিক্যালি চিন্তা নাও করতে পারে। There is one more great discovery, with no time to discuss this, which is called the Gödel's theorem. আমরা আইনস্টাইনের গ্ল্যামার অফ রিলেটিভিটি থিওরি and Heisenberg-Schrödinger's theory of the quantum mechanics and wave mechanics, that is well known. But one theorem which is less known, which is one of the most revolutionary theorems of the modern times, called the Gödel's theorem. I will not discuss it now. The logical formulation of the human brain, that is the final word, should have completely destroy করে ছেড়ে দিলেন। Human mind need not always think logically. যত ইললজিক্যাল চিন্তা করবে ততই কিন্তু নতুন নতুন ডিসকভারিজ হবে। সেজন্য আমাদের দেশে হিন্দু ধর্মে বিশেষ করে আমরা বলি যত পাগল হবে ততই কিন্তু নতুন নতুন জিনিস আসবে। বিজ্ঞানীরাও পাগল, ঠাকুর শ্রীরামকৃষ্ণ পাগল বলেছিল ওরা, যত পাগলামি হবে ততই কিন্তু নতুনত্ব আসবে। আনফর্চুনেটলি সায়েন্সের ছেলেরা, প্রযুক্তির ছেলেরা, মেয়েরা কোনো সাহিত্য পড়ে না। আমার খুব দুঃখ হয় এটা। আমি যখন বিদ্যামন্দিরে প্রথম এসেছি, সায়েন্সের ছেলেদের জিজ্ঞাসা করেন, তোমরা রবীন্দ্রনাথ গীতাঞ্জলি পুরো পড়েছ তো? উত্তরও দিচ্ছে না। না কী হলো? হ্যাঁ, আমরা সায়েন্সের ছাত্র তো। লজ্জা করে না বলতে? সায়েন্সের ছাত্র মানে কি লিটারেচার পড়বে না? সেখান থেকে ওটা আসে। রবীন্দ্রনাথ সুন্দর একটা কবিতা আছে পাগল, বলে অবশ্যই পড়বে তুমি গিয়ে। উনি বলছেন অনেক বেশি সুস্থ মস্তিষ্কের লোক এত বেশি আছে জগতে, সেই জন্য জগতে কোনো উন্নতি হচ্ছে না। একটু অন্য রকমের লোক একজন আসুক, লেট দেয়ার বি সাম পিপল হু আর নট সেন, so that discoveries are possible. এখানে উনি বললেন তো Gödel's theorem প্রমাণ করলো মানুষের মস্তিষ্ক অ্যালগরিথমিক্যালি চিন্তা করে না, নতুন নতুন আসে। একটা এক্সাম্পল বলে শেষ করছি আমি। Srinivasa Ramanujan, who is less remembered now, came out with those extraordinary theorems. কেমব্রিজে নিয়ে গেলেন আমাদের দেশ দুর্ভাগ্যবশত আমাদের দেশটা ওকে নিতেই পারলো না। So Hardy used to come up with his notebook full of theorems. Hardy used to ask him, Ramanujan, what is the proof of all this? Sir, proof? I see that they are true. আমি দেখতে পাচ্ছি এগুলো ঠিক। ঠাকুর শ্রীরামকৃষ্ণ বললেন না, ঈশ্বর আছেন কিনা প্রমাণ কি? প্রমাণটা যে আমি দেখতে পাচ্ছি, প্রত্যক্ষভাবে দেখছি, তোকে যেমন দেখছি তার চেয়ে বেশি প্রত্যক্ষ দেখছি। You see the truth. Then Hardy asked him, where do you get all this from? কোথা থেকে পাচ্ছ বলো তো? Sir, that's a secret, sir. বলো না তুমি। আমি রাত্রে যখন শুয়ে পড়ি স্বপ্নে দেখি আমার কুলদেবতা, my goddess whom I worship, Namakkal goddess, Namagiri goddess, she comes and tells me in my dreams, sometimes writes in letters of blood. সকালবেলা এসে আমি নোটবুকে লিখে আপনার কাছে নিয়ে আসি। তখন Hardy is supposed to have said, this boy undoubtedly is a mathematical genius, but hopelessly religious and spiritual. After hopeless spirituality comes creativity, after that comes science, after that comes technology. So let us all be hopelessly intuitive and spiritual so that you can do better science, and always remember Sarva Bhuta Hiterataha. Bhagavad Gita talks about it, Upanishads talk about it. সমস্ত মানুষের কল্যাণ যেন হয়, সেই কল্যাণের জন্য আমরা বিজ্ঞানকে প্রযুক্তি ব্যবহার করতে পারি, তাহলে আমরা মানুষ, তাহলে আমাদের বিজ্ঞান প্রযুক্তির দরকার নেই, মানুষের কল্যাণ হোক। চারিদিকে দেখলে হোয়াট আর উই ডুইং, ওয়াই আর উই ইনভেন্টিং অল দিস? মানুষকে মারার জন্য। করোনা আমাদের ভালো করে দেখিয়ে দিল, tiniest of the tiny virus, all your Nobel laureates and all your virologists and biologists সকলে flat হয়ে গেল for more than 2 years and a half. We had no answer for corona. So nature, if you pry too much into nature and misuse the gifts of nature, nature will come back with nature's nemesis. প্রকৃতির প্রতিশোধ বলে এসে এমন একটা থাপ্পড় দেবে, মানুষ কিন্তু শিখতে বাধ্য হবে। ওই থাপ্পড়টা খাওয়ার আগে যেন আমরা কিন্তু জেগে উঠি, বিজ্ঞান প্রযুক্তিকে মানুষের কল্যাণের জন্য ব্যবহার করি, এই বলে সকলকে ধন্যবাদ জানিয়ে আমি শেষ করলাম।
Thank you. Thank you, Swami Atmananda Priyaji, for your immensely enlightening talk. I again request Professor Debashish Kole to take over the proceedings.
Thank you very much, Swamiji, for that enlightening, inspiring address. And I should say, sir, that you are always most inspiring personality in my life. They had started from my career as Belur Vidya Mandir, when you were the then principal, and I have the great opportunity to be in direct interaction with you from my college days. And I think now
I could not stop myself for 3 things, 30 seconds each. One is a quiz for the students. In today's day, what is the best technique to detect microplastic and nanoplastics in the samples? You can answer later if you don't, but answer this, it is relevant why I'm asking. Second is, this is a marketing for us. ISER's admission test is website is going to open tomorrow, and I encourage you to apply. And third is, it's a coincidence, but great coincidence. We have Director of IIT Kharagpur, the first IIT in the country, and this day at the first ISER of the country. So we are very proud and privileged, and I welcome Director for this. So this was 3 things I wanted to say. Thank you.
Thank you, Professor Khariji. Now the floor is open for some questions from the students. So questions, students, তোমাদের কোনো কোশ্চেন থাকলে তোমরা হাত তুলতে পারো। কোনো কোশ্চেন্স আছে? মহারাজ এখানে আসেন, এত ইন্সপায়ারিং আমরা শুনতে পেলাম ওনার কাছ থেকে।
এমন ইন্সপায়ার হয়েছে কোনো কোশ্চেনই আসছে না ওদের, হয় ঘুমিয়ে পড়েছ অথবা কোনো প্রশ্ন নেই।
ও স্টুডেন্ট নয়, কিন্তু প্রদীপ, Professor Pradeep Tarufdar from Department of Chemical Science. Pradeep.
Maharaj Pranam. So it's more spiritual probably, that why Namagiri choose Ramanujan, not the others?
Nobody chose anybody. Ramanujan chose Namagiri. Nobody chose anybody. You should remember the Namagiri goddess is only a name for that higher intelligence which was already there in Ramanujan. Nothing comes from outside. Every one of you, every one of us has that intuition. Every one of us has that potential science in us, potential discoverer, but we have not brought it out. So Swami Vivekananda therefore said, it is the manifestation of the potential perfection in you already, it is education. So you have to manifest that, not that Namagiri is only a name which came. So he's some higher potential he awakened within himself. Unfortunately, we always go through the logical process. Logic does not always reveal the truth. Logic only codifies, systematizes, and leads to technology. But those who can think not illogically, not logically, but beyond logic if you go, from there intuitive flow comes, and the logical mind only codifies it. What you call the Namagiri goddess is that higher mind which is in everybody, which has to be awakened. That's why Gayatri Mantra was given to every student as soon as he enters the Gurukula, so that within about 10 years his higher faculties are awakened. Unfortunately, in our system, which was the ancient system destroyed by Lord Macaulay, he said first memorize and forget everything about ancient India. Every one of our education institutions, the first thing they should do during the freshers' welcome, all of you now repeat the Gayatri Mantra and meditate upon this. Immediately there will be a furor everywhere. We are trying to do something which, this is the minimum that you awaken the individual potential within us. It's only a name which is given in a very figurative language.
Thank you, Mohan.
Thank you. There's one question there, raised hand. Yes.
Sir, I am Shrestha Roy
can go
from
for
class
English,
8A.
Hindi,
Sir?
English, Hindi, Bengali, Tamil.
English.
No.
I am Shrestha Roy from class 8A Oriental Public School. My question is, what are the finest literatures we should read to enhance our inner knowledge of science?
Oh, plenty. Nowadays we had one old book called The Nature of the Physical Science by Arthur Eddington. It's a very old book. 1930s it was written. Such a piece of literature it contains. Feynman's lectures are also pieces of literature. George Gamow, who wrote so much about science, 1, 2, 3, Infinity is a very famous book. Jules Verne, a lot of science fictions he wrote. So many books are now coming out, have come out. You just casually read those like stories. Plenty are available now.
Thank you, sir. Sir, I have another question.
Yes, please.
That you told the Gödel's theorem or something. Can you explain
Gödel's
that?
theorem. Now there's a lot of time is very less. Gödel's theorem is a very peculiar theorem. And just 1 minute, can I take? See, you must have heard of Bertrand Russell and Whitehead. Please sit down. Whitehead and Russell were two pioneers in formalistic logic. And like Newton's Principia, they had a mathematics Principia, and they were swearing by mathematical logic. Everything will go logically, everything will go mathematically. Then came Gödel, is pronounced as Gödel or Gödel, pronunciation I'm not very sure, is an Austrian perhaps, in which he proved that everything in science, everything in the world cannot be proved. There are, very simple language, there are certain true statements which are neither provable nor disprovable by any system, by a logical system. You can't prove it, I can't disprove it, but they are true. Just like somebody says, you believe in God? Yes. Can you prove God exists? My question is, can you prove God does not exist? You can't prove God does not exist. I can't prove God exists. Let us be at peace. There are certain fundamental questions which can be neither proved nor disproved that can be intuitively understood. This has simply demolished the entire structure of formalistic logic. It never could come up, which means human mind has the capacity to think out of logic, beyond logic, but not illogical, not fully logical, but there is an aspect called intuition by which human mind can intuit certain truths, and the logicality comes much later. Logical formulation comes later, but you suddenly intuit certain truths. Yeah, this should be like this. In ordinary language, ordinary life, we call it gut feeling. Gut feeling means, I think this is true. How do you know? I don't know, but I feel. That means human mind and heart have the capacity to feel. How to cultivate this? Our scripture said, Mano Hridi Nurudhya. That is a statement in the Bhagavad Gita. The mind should be merged in the heart. We usually in science and technology, we speak through the mind and not through the heart. When the heart gets involved, higher intuition is awakened in the heart, and logical mind also enters into this. A new equation, new movement starts within you by which you are able to intuit several things. You immediately, this should be right, this should be this way. Even ordinary life also you should know, this is what I am needing. So ordinal theory, please read about it. It's available everywhere. You can Google it immediately. This is one thing all of you should seriously think about this. Not much work is being done on that. I wish some of you take this very seriously.
Thank you, sir.
I think with due to the interest of time, we can postpone this question and session. Maharaj ji will be there after the session for witnessing some of the science exhibition outside. We can then continue the question and session now. Thank you, Maharaj. Now, move forward with the next part. It gives me immense pleasure to have with us Professor Suman Chakravarti, the chief guest of this event. So, may I introduce Professor Chakravarti today. It's National Science Day. I welcome him here, a renowned professor of mechanical engineering and director of IIT Kharagpur since June 2025. A brief CV of Professor Chakravarti. After completing his BE in mechanical engineering from Jadavpur University in 1996, he completed in his ME and PhD from ISC Bangalore. So subsequently in the year 1999 and 2002, he started his career as a lecturer in the Department of Mechanical Engineering at Jadavpur University in 1999 and joined IIT Kharagpur as an assistant professor in 2002. Since then, Professor Chakravarti has been serving at IIT Kharagpur as a teacher and researcher. He has been recognized for his pioneering research in microfluidics, nanofluidics, and affordable medical diagnostics. He developed low-cost healthcare solutions for diseases like cancer and COVID-19. Professor Chakravarti has authored over 500 publications in national and international journals and has guided around 50 PhD theses to date. So he's, of course, a very illustrious figure. He has numerous recipient of numerous awards and fellowship. He's a J.C. Bose National Fellow, Fellow of Indian National Science Academy, the Indian Academy of Science, the National Academy of Sciences, India, and National Academy of Engineering. His international fellowships include Fellow of Royal Society of Chemistry, Fellow of American Physical Society, Fellow of American Society of Mechanical Engineering, and many more. He's also the recipient of the very prestigious 2022 Infosys Prize and the Santi Swarup Bhatnagar Prize in 2013. With this, I request Professor Chakravarti to deliver today's lecture on the National Science Day event.
Thank you very much, respected Professor Khare, the director of this institute, Pranam Maharaj, and Professor Narayan Chakravarti, our role model, distinguished faculty members, students, and students across generations, what I understand, from school to higher education. I belong to an educational direction where sometimes I forget, am I a science student, am I an engineering student, or am I a nobody student? In the backdrop of the National Science Day, it is therefore a reflection of some of my thoughts that in the modern, what we call as very complex and transforming world, it is science without walls in an absolute literal sense. Perhaps that is what we are all talking about. I will give you a context of why we are tempted to think in a different way as compared to what possibly we used to do several years back. We all grew up with a knowledge where a lot of advancement came through industrial age. But currently, whatever it is, in a terminological manner it is called as intelligence age. It does not mean that people were not intelligent earlier and suddenly became either highly intelligent or less intelligent because AI is taking over humans. Whatever it is, I am not getting into that, but AI, automation and open web revolution is creating an havoc in the way in which we are rather compelled to direct everything in life, not just science and education. But then human-centric challenges also need empathy and ethics, and there is no natural way by which we can embed that in the curricular framework. There is a rapid revolution and evolution of the required skill sets, making the learning obsolete very quickly if it is just content based. At least in our student life, whatever we have learned in our college education or higher education in general, we knew that if we are in an educational field, for quite some time that will remain relevant. How long we did not know. But now, maybe what is being learned today, after 6 months that may not have any kind of practical relevance other than getting marks in the exam. So this rapid transformation of the needs makes the content based learning very shallow, and a challenge to the educationists is coming on time and again, where no matter we talk about the standard teaching learning has been primarily framed on delivering contents, but if the content itself is going to be dynamic, then what is the different way in which you teach the contents, but you teach something more inner through the contents rather than exactly what the contents read. And even when we talk about contents, explosion of materials. When we were school students, we used to think someone, a great history teacher, who would remember in which year what battle was fought, give great in-depth narratives of every vivid thing. Now, someone with just a finger touch of the smartphone will get 10 times more that material. Whether correct, authentic or not is a secondary level, but explosion of material. And then it has to be taken into account that in that backdrop, the sanctity of content based education, and more so in science and technology, how we are going to treat it. So, shift from information based paradigm to knowledge and skill synthesis for problem solving, and problem solving does not necessarily mean that solving a problem in the exam. It is solving a problem in maybe society, life, and so forth. So, now in this backdrop, what I am going to talk about will make a bit of sense if we go back to the traditional style of science education per se as an example. So, we talked about physics. Someone who knows physics is of course in a vertical of physics. Someone in chemistry, of course people would argue that at some level you have physical chemistry, chemical physics, and in fact there is a journal titled Physical Chemistry, Chemical Physics. But then that kind of thing will always be there. But we knew that there were established strong foundational components, and why science has advanced so much is because it specialized at some point of time this much. Then one could get into that depth and rigor, and it could dissect whatever depth required and reduce the complexity into some analyzable fragments, which each of these became say either textbook topics or research topics. But science in the 21st century must also integrate, not just dissect. We stand today in a world where this kind of disciplinary silos, they are dissolving because it is very difficult to demarcate. So, we talk about in science miscible and immiscible substances. So, if you have two immiscible things, you can form an interface, but miscible, if you keep them, you cannot really make an interface. So, the grand challenges before the humanity which are at present there, like climate, pandemics, sustainable energy, equitable healthcare, resilient cities, they do not arrive as a problem in physics or a problem in engineering, or maybe a problem in chemistry or a problem in biology, and these are systems problems, a problem that we have to solve. In a simple way, let us say that we are not getting water in a community. Now, is it a civil engineering problem or is it a municipal decision flow problem? We do not know, but we have to work it out. In my own journey, I have never systematized my own journey, and I think that has been the strongest and the weakest point of my own journey. When I was in say class 4 maybe or even less, I wanted to be a bus driver. Why I wanted to be a bus driver? Because first of all, I could study what the bus drivers used to do very clearly. We had a big bus stop in front of our home at Kolkata, and whenever I used to get into the bus, I found that the driver has a great command with the steering, and the conductor is someone who is a bit less in stature, and the driver, in a way, the way he could navigate the road with a lot of steering control and all, I thought, yes, I want to be like this. When I was in class 10, maybe class 9 or 10, we had an excellent biology teacher, but I thought that this is not my subject, because what I felt is that I wanted to study in-depth analytical science, and I felt that physics and maths to an extent is giving it, junior school chemistry is not giving it. It is maybe my fault, or I do not know, whatever content's fault. So many of our friends used to jokingly talk about chemistry at the back, chem history, because we had to remember so many things just like for your history, in which year what was what happened. And biology, you just, it's fully history, not chem history. So I thought that I must find a structured way to escape from biology. So when I came to class 12 or class 11 rather, 11-12 level, in our time there was a concept of fourth subject, which is like you can say elective, because modern day maybe the terminology is a bit different. So you take the basic subjects as, in addition Bangla, English, you take physics, chemistry, mathematics. Fourth subject, I had a choice in our school. In those days there was no AI coding, those things were not absolutely existing, statistics and biology. So I thought I must take statistics, not that I had great love for statistics at that time, but I can avoid biology in that way. And my parents will never be able to force me for the medical JEE exam. So that was the algorithm, the trick that I played. Now, if you consider it as a flashback and maybe say 10, 15, 20 years after that, the day on which I was appointed as the head of the School of Medical Science and Technology at IIT Kharagpur, for whatever direction of fate which in my research and etc. that happened in between, as a black box, some of that I will give some glimpse. So in the Facebook, I was having a communication with my school life science teacher, who by that time knew that I was doing reasonably well at IIT Kharagpur, but he did not know exactly what I was doing. So, but when I communicate, he was giving some response and all. He is a much busy teacher than me, because he is very famous in his biology coaching. So he gave some inputs here and there, but when I told that, sir, I have become the head of the School of Medical Science and Technology, I think the greatest shock that he got ever in his life. He will never tell that. So he just became, dead, dumb, stop. Nothing could progress beyond that. And then when I, those statistics classes, which were at that time bit of time passing class, now when I read some of the machine learning books, I see so nicely they have come with a new avatar with old wine in a new bottle, and I feel so happy about it that unconsciously what I took as a subject now is very important for learning machine learning. So who knows whatever is required at what point of time, and if someone just to sort of praise me tells that I am like a missile and doing very well, I would say absolutely unguided missile. Where it goes you do not know. So then, but what I have sort of, if I could make a summary of my learning, and which is related to this particular topic, that foundational studies in fluid mechanics, micro nano systems, biomedical interfaces, I have witnessed a profound shift within myself. What Maharaj was talking about, that what is in your inner self you possibly try to discover and get into it, and that is one of the hallmarks of your own learning. You do not see, we talk about system, we talk about surrounding. Sometimes we do not bother much about surrounding. As a system we are growing, and that is also it happens within your inner self. So from equations describing some idealized flows to blood flow in living microvasculature, from microfluidic channels in silicon to some point of care diagnostic platforms for low cost disease detection in rural communities, and from controlled lab validation to deployment in extreme climate vulnerable regions like Sundarbans. And my learning, which is actually again what Maharaj was talking about, that that I have not learned anything actually, that the lab is no longer an end point, it is a beginning. And I feel so frustrated that when my student life theoretically has been over long time back, teaching life 25 years have been over, now I realize that lab is just the beginning and not the end point. And more or less all the time we have spent in our lab. But then this is also a realization, what can I do? So what I want to talk about, and I want to give a disclaimer because sometimes we have to tell that photos, images, sources, etc. So these are all the photos and images other than the real experiments that I will be showing, that is these poster type of things, are made by me using ChatGPT. So let me tell you very clearly, but the kind of prompt which is required is a bit of a skill and training. Not everyone will be able to do it that easily. So now what I want to emphasize on is that from reduction approach to a convergence approach, where all science, engineering, knowledge is converging to solve a problem, and how that all is happening. Science in the living world, the world where we all live. The living world is uncertain, it is non-linear. Sometimes I have very peculiar knacks, and these knacks are not related to anything which can give me professional edge. So I in my leisure time record video lectures for class 5, 6, 7 maths in Bangla. So I have a list of that, and these are going to come up soon through our now NEP focus with regional language and school connect program, and we are going to bring that up. So once upon a time when I just thought it as my own leisure and pleasure, it will come and people can see. So what we most wrongly learn in school is the absolute acceptance of unitary method, which is a linear projection. So if 5 number of people in say 10 days do 1 unit of work, then 20 number of people for doing 10 units of work will require how many days? All of us have done those work, those kind of problems, more complicated in that case in a style, but there are simple versions also. So all those will project a linearity, but you realize typically some people who run business, that now look at the modern banks. So 4 people used to do one work, now there is one manager who does 4 people work, he does not get 4 times the salary. So he does 4 times work, he gets much more salary than the previous anticipation, and the company also gets satisfied because the work is done. So this is a completely non-linear world, and it happens everywhere. So in fluid mechanics, which has been my subject from my first day of specialization till what I am doing currently, we were once satisfied predicting simple laminar flows between 2 plates, because there was a time when it was also not trivial. Today we simulate such phenomena in deformable biological tissues coupled with electrical field, molecular interactions, AI enabled prediction, which we call as physics informed neural network. I am not getting into that topic because it is a very exciting topic, possibly on another time I will talk about it in a more focused way. In material science, we no longer ask merely is it a strong material, we ask is it sustainable, is it circular, is it scalable, is it equitable. So many other requirements which come from humanistic and deployment considerations. In biomedical engineering, a device is not successful because it works in a lab. It succeeds only when it survives cost constraints, field variability, regulatory constraints and social acceptance. You make a technology, someone in the deep rural space just throws it, I do not need it. Then why are you making this technology? So this transformation science must embrace from proof of concept to proof of impact, from publication metrics to societal metrics. and from disciplinary depth alone to convergence intelligence. Now, I will just give you a snapshot, as I told that my complete journey has been unplanned, but you know this very commonly happens that you have lots of unplanned things, someone tells that you make a story out of it. So then we take the cow to the burning ghat, what we say, and then when the essay of burning ghat is to be written, you write the essay of the cow, because you know the cow essay reasonably well. So I started my early career in working on processing of materials when they are changing their phase. So you have a system where you have solid and say liquid, liquid is due to melting, and you have a dynamically moving interface. And the science of that was my primary objective, but then to apply it to certain industrial processes like laser materials processing. In modern times that has got adapted to additive laser assisted additive manufacturing. Now what I realized, this I realized after I developed a lot of further maturity. What I realized at that time was not this one, but now I realize that I was essentially working on problems with dynamic interfaces. If you say as something which is a physics wise fundamental, and these if you are working on a say numerical or a computational simulation problem, these are you can say moving boundary problems in general. And moving boundary problems, let us say you have a droplet or a bubble and it is evolving in a fluid. So that is also a moving boundary problem. And in fact, these are the problems which these are not ChatGPT generated, these are our own research problem. So then what we realized that well we are talking about droplet, but the droplet has a fluid-fluid interface. If you now have a membrane around the droplet, or think in a different way, you have a small balloon filled with water. So you do not have a fluid-fluid interface, you have a membrane fluid interface. This is called as a vesicle. Very important in mechanics, but the question is why it is important. It is the most simplified model of a cell. So imagine that the balloon is like the cell membrane and the water is like a cytoplasm. So if you can upgrade your knowledge from there to the cell, and that knowledge is unlimited because cell has absolute different levels of complexities. So what we can at least imagine, if we connect all these things, that you have of course extreme nonlinear phenomena, and this extreme nonlinear phenomena in many cases they become more uncertain if you are trying to address or understand those phenomena not in the lab. Lab is very important for science research, and to an extent that glamour in the lab often drives the perception of glamour of science. So now at some point of time, again this did not come by logic, I started thinking about it, that whatever we are doing, that fluid flow through small channels etc., can we use that to an extent that it can impact lives. So I will give you a bit of glimpse. Let me see if this movie runs, it may or may not, yes it is running. So if you see here just the movie that is going on, there is a small box which is like a black box. Inside that you have some controlled optics and electronics. Then what you are doing is you are trying to do a blood test, but the blood test by not winding that tube around your veins and take the blood. So it takes 1 drop of finger prick blood, just like the home sugar test. Then it puts it on a strip. The strip has microchannels. So if you drop that blood by microchannel, the blood will move. You do not require any pump because it will move by capillary action, which is surface tension driven flow. Those of you who are from school, you will know that in the plants there is ascent of sap. That is, water and nutrients are sucked from the ground and they will go to the tallest of the branches, but there is no pump inside the tree. This is because of the surface tension and capillary action. So same capillary action. Now when it reaches a spot, in the spot there are some reagents. So this is chemistry. So the reagent reacts with the blood or the plasma, which is the watery component of blood, and it is separated within that small piece of paper. And then you are having the reaction between these two and a color is produced. Very common reactions we study in school where A plus B some C plus D with a change in color. Now this change in color very commonly in school labs we see by litmus paper. But that is very subjective. It gives blue, red, etc. But what you want? You want that blood contains how much sugar concentration? Say 100 milligram per deciliter or what? So to differentiate between 100, 101, 102, etc., you need to quantify that color, which was very challenging previously, but now with outstanding image processing and deep learning algorithms which have come through AI, it is not that challenging anymore. So what we do is typically create an illuminated environment within that box, so that on that strip with a particular illumination the light focuses, therefore the color that illumination background is standardized through that box. You take the image, do the image analysis, which is typically this computational and data science, and then whatever comes out of analysis, those features you correlate with the value of the sugar, which the other part of the sample you give to the standard lab where the automated biochemistry analyzer machine is used to get the sugar value, and you compare. In that way you prepare a calibration which is not like a standard graph x versus y, because there are many features which are combined to give the calibration, and that is how it is a machine learning based. And you can make it dynamic in a sense that your technology says some value of sugar, actual value in the gold standard something else, that difference is a corrector that gets into your next training of the method. So that is how a bit of AI is embedded into the system. So if you look into it, of course the purpose is that you can do a simple low cost test in a low resource setting where there is no requirement of a lab. You require the paper strip which is like the credit card and the box which is like a credit card reader, and anyone can operate it. The objective is well understood. Now you look into the subjects. You have physics, chemistry, data science, all integrated together to work on this problem. So can anyone tell that is this a problem of physics, chemistry, engineering, what, bio? You do not know. Now when we worked on these subjects, every learning in such a subject actually tells you what you have to do more. In science, I feel that this self introspection is very important. I know that all of us who are passionate in science, when we come up with something, we get excited. But sometimes that excitement becomes possessiveness. Like we are all very possessive about our own children. So only a third person other than the parents will have a different eye on the child and tell what are the limitations, and possibly for parents it is very difficult. But if you take away that possessiveness, you will find there some obvious limitations. So, one example, let us say the blood is moving by capillary action. It cannot be very fast, but let us say you want to do an ultra rapid test. So, you want to make the blood move fast. How you can do that? One possibility is you apply electric field, because the paper in which you are making the channels by which this capillary movement is taking place, it is actually one of the very unique things where the cellulose fibers which are there, they have a negative charge at their walls. So, overall the fluid is neutral, so if they have negative charge, the bulk of the fluid will have positive charge. So, if you apply electric field, the charge will move in a certain direction, and what will happen is that because of the fact that ions are hydrated, the fluid will by itself be pulled, and this is known as electroosmosis. Now, to do that you require electric field, but again you wanted to simplify something, but to deposit electrodes you go for a bit of you need to go for some sophistication. Electrode deposition in a small system requires a sophistication. So, at that point of time when we were working on this topic, the idea that came to my mind is that our pencil tip has that lead and lead has graphite. So, if we just scratch pencil, is it not maybe an inefficient, but one of the ways of graphite deposition? So, we did it like that, and what you see here is these black square regions, those are basically HB pencil sketch. So, you have a paper in which you have HB pencil sketch, you connect them with wire leads and put a battery. Anyone in class 6-7 can do this. I mean, there is absolutely no complexity about it. So, when you do it, initially my students were a bit they were not very positive about it. They thought that it can't be this simple and it is a bit of a bad idea. But then when it worked, they were happy, and I did not realize that in that process we were the first inventors of a new subject altogether, paper and pencil microfluidics. The first publication of this, when it came up in 2012, I did not realize that it will be cited and so many people will be using it, but then I realized that one of the unique aspects of this is its simplicity. Of course, you cannot scale it up like everyone sitting with a pencil and making a kit, but you can automate this graphite deposition using the same principle. I am trying to get into different general problems rather than maybe how to detect cancer, how to detect this and that. So, because this is National Science Day, I wanted to focus a bit more on the science and instruments, like remembering the legendary works of Sir C.V. Raman. Now, when you are in a life science lab doing some study, very commonly you require a very powerful microscope, and any school life science lab will also have some rudimentary microscope. College will have more, university, etc. So, I will give you an example where we wanted to study that if in the blood sample there is very little concentration of something, how can you detect it? It is a very challenging problem, because many of you may or may not be aware of that for cancer there are certain common inflammatory biomarkers which can be used for screening from the blood sample, but at early stage they are so much low in concentration that standard instrumentation, unless fabulously expensive, will not be able to pick it up. In the diagnostic language we call that they are not sensitive enough. So, what do we do about it? So, what we did is, I am not getting into the details of the technology. So, let us say that we are trying to detect a protein or an antigen, say CA125, a cancer antigen. So, what we are trying to do is, antigen loves antibody. So, antigen antibody binding can take place and when antigen is binding with antibody, if there is a signal and if you can detect that signal, that means that antigen is there. This is a simple way of detecting it. Now this is simple in principle, so if someone tells me to write it in class 7 language, this I will tell, but it is not that simple. So what you do is that you have that same paper microfluidic system, which is a collage of different porous membranes one after the other, which is called as a lateral flow assay. All of you have seen it, you may not know its name. All the rapid diagnostic kits of COVID which are available in the medicine shop are these lateral flow kits. So now if you pass that whatever, you can pass blood, saliva, swab, etc., and you do not require a pump, by capillary action it will move. So the sample will carry this antigen, and there are some antibodies which are put on this paper or the membrane. So if that antigen which you wanted to catch is there, it will bind with its corresponding antibody, and these antibodies are tagged with carbon dots. Now this antigen antibody complex, that binded matter, by capillary flow they will also move, and you have a station where you can catch them by another antibody, which is called as a secondary antibody. So if they are caught there and trapped, normally what it will do is it will generate something which in physics known as surface plasmon resonance. But if you want to amplify this signal, this carbon dot, and if you excite it with say ultraviolet light, so it can emit fluorescence of specific wavelength bandwidth depending on the specific binding. So the fluorescence color may appear to be pink, green, depending on the spectral range. So to that extent, a minute amount, if it is also there, it will emit that. But how do you detect? Then again that challenge comes. You need a spectrophotometer. I imagine that in deep Sundarban someone is doing the test, suddenly realize that you need a spectrophotometer. So that is not also compatible with on ground facilities. So then what we do? So what we realized, and this is where our bit of training as engineering students helped, that we gathered a few of these lens with objective eyepiece etc., and procured about 1000 rupee total material and combined that to form a simple microscope with which can, this combining all the optics can give 1000 times magnification. Then you have to house them. So we made a 3D printed box with our 3D printing system and put that inside this. So a simple handheld microscope, and we made it in a way that on the top of the microscope is a holder of the smartphone, and at the bottom is a slot through which you can insert that strip where that antigen antibody reaction is happening. So with all this excitation, this when it emits with a magnification it is visualized, and that is recorded by simple smartphone camera. All the examples that I have been talking about, they to an extent depend on smartphone, and all of us know that what kind of cars the modern day smartphone is. People have lost their concentration, young children are suffering because they get such an addiction they cannot come out. But it is just like that when that nuclear energy that came up, it could destroy a civilization and it could also be used for cancer treatment. So the same thing, you can make this smartphone a beautifully adapted material along with this supportive small system. So you get in the smartphone image an outline which is nearly not as of good quality as a fluorescence detector, but you can calibrate it with a fluorescence detector which is there in the lab and extract the features from the image and use this deep learning for your image analysis. So that is where your AI comes. So where I want to emphasize on is that typically for the young students, that AI is very important, but AI in many of these applications is topping on the cake. If the cake does not exist, topping is not required. So, you may get fancied by autonomous vehicles, but the vehicle does not have an engine. So, what the autonomous vehicle will do? So, that we have to keep in mind, and several other tests that we developed in this framework. One was during the COVID, we developed a COVID rapid diagnostic technology for COVID, which was ICMR certified, and when COVID period went away, we tried to adapt that for TB diagnostics, and currently with ICMR we are working on developing a kit for that. Now, as I told you that so far I have talked about the technologies which require some devices, maybe small whatever, but require devices. But wish is that if there was no device, that means you do a sugar test without a glucometer. Someone will say that why without device is required, what is that cost? Nothing much. I would say that yes, that cost may not be that much, but also convenience. Even if you can afford that cost, let us say busy people in a airport, in a flight or a meeting, and has to monitor the sugar, suddenly bringing out that box and that meter and starting doing this, it is so inconvenient. So, the wish is, if we had the strip in the pocket and smartphone is also there in the pocket, I will just sit like this, when someone else is presenting, I will very slowly do my test. So, if one has to do that, then that box has to be gone, and if the box has to be gone, you are absolutely on soup, because every smartphone, if you are relying on smartphone only, every smartphone has different camera setting, different background illumination, and user can be erratic. So, with all these combinations, you can possibly never standardize your image analysis. So, what we did is we played some trick with AI and physics combined together, the deep optics coming in with that, and creating a relative reference frame. So, with the help of a company called a Smart QR, whom we incubated at IIT Kharagpur, now they have brought this product to the market. Two typical products, one for anemia screening, hemoglobin detection, known as Hemo QR. So, why such a name? Hemo for hemoglobin and QR is a QR coded strip. If it works, let me see if it runs, if not, at least one of those works. And PrePap QR is a highly accurate vaginal pH test for women, and they can do it at their own privacy without going to anyone else. Just you have to self collect the swab and do the test on your own on a paper strip, take the photo on the smartphone and send to your preferred gynecologist without being sort of intervened by anyone. So, we have implemented these in many different places, including Sundarbans, and I feel so happy that in Sundarbans those women, they have got trained by the video and they are themselves now working and doing the tests. So, if you summarize many of these tests will have some AI component and some physics based component which come through a technology. So, the whole 360-degree map of the science and technology. So, we have developed, initially we developed an oral cancer screening technology where you use a thermal camera. So, you have a torch like thing, inside the mouth say there is a lesion, it is taking a non-invasive 30-second picture, thermal image, and we have a proprietary method by which it is converting the thermal image to how the blood is perfusing over those tissues. And this is completely physics of fluid mechanics and heat transfer at small scale. I am not getting into that, but the whole idea is see how from there to what we are thinking about. So, you have that method, but now someone says that there is a patient, I need to do a screening. So, that is a method, but it is not something which is a gold standard method. So, do I have something more? So, whatever are the common inputs, clinical inputs or patient given inputs, those and these can be combined into a clinical decision support through a AI based technology. It is not a replacement of a doctor, but it saves the doctor's time and effort and gives an analytics to the entire quantitative scenario of the patient. On the top of that, there is doctor's wisdom. Till now AI cannot replicate that, but it is just to complement. So overall, it is from reductionism to convergence. Instead of thinking about which subject, science, engineering, etc., how we can get into convergence of technologies which can impact the last mile, like in the Sundarbans or in the rural Bengal. And in the process, I have never really realized that we would be having such a pleasure. So many young boys and girls in the extreme rural places, they have started earning their livelihood out of this entire ecosystem. So this I can say is a derived benefit. I never thought about this, but it happened. So science in the living world, if we say that on one side you have lab discovery, on the other side you have real world applications, and you cannot really say that which one is more or which one is less important. Had you not have that lab discovery, that real world thing will never happen. So that fundamental lab work has to be given due importance. But at the same time, we have to recognize that the future belongs to those who, instead of differentiating this lab and living experience, can synthesize them together. And so many different disciplines they will all demand to work with. And it is very important that as the present generation students and researchers, one reimagine scientific education, where these things automatically come as a part of our learning process. So we must train not only problem solvers but problem framers. Sometimes I say, and I have given this exercise to many of our colleagues, that this give 4-year undergraduate questions to ChatGPT. It will give almost 90% more answers. So you give ChatGPT the undergraduate degree, why the student? So many times the quality and the prompt and the nature of the question and verifying the answer and refining that is a better skill as compared to the naive skill of getting answer from some book and highlighting and memorizing. So in that way, National Science Day, with all these aspects and the challenge all these aspects bring in. When we were students, we used to write an article, science blessing or a curse. Now, perhaps you replace science with AI. So you really do not know. People can deep fake images, videos, imitate the voice, can show anyone hugging another person in the image and what not. So one has to be ethical, and that element also needs to come. So the scientific education and typically the India-centric perspective, we have numerous challenges deep rooted in India, but we have an extreme demographic dividend, digital backbone. In the digital space, India is very advanced, and we have huge, widely varied data, and that makes the India-centric problems being approachable in a way which is not so easy for many others. And my only emphasis to this is that if we want to become leaders in science and technology, we should shed away this mind, someone X in a great lab in USA doing nanotechnology, so I should also do nanotechnology. Identify our very complex problems, and with those complex problems, you use this multi-pronged approach to get a solution, then we will be scientific leaders. I just want to end with a IICR perspective, because I have come to a particular institute. So these institutes, and we are all proud that this has been the first in the IICR system. These were envisioned to restore the primacy of science, science driven by curiosity, not immediately by commercialization. This is very, very important, and that role is more critical now than ever. Curiosity driven science and impact oriented science are not opposites. They are phases of the same continuum. They must exist together. You cannot forget about fundamental science and say you will be building up newer and newer technologies. When Sir Raman explored the light scattering, he was not thinking of the optical diagnostics that currently they are happening. Yet today the entire technological ecosystem, one particular vertical stands on that foundation. So the mission of IISc here, and that is where I find that it has great promise and hope. I will appeal to all scientists, do not merely study nature but decode its complexity. Do not merely publish knowledge but expand human capability, and do not merely work with labs but transform the living world beyond them. Try to extrapolate the science, and then it becomes a different celebration of science, as we say on the National Science Day. So 3 calls to action. Dare to ask unfashionable questions, even if there is no silly question. If a question is coming, it is coming. Build bridges across scales and disciplines, and measure success not only by citations but by transformation. These are the 3 main messages that I want to convey before my conclusion. Thank you. Namaskar. Jai Hind.
Thank you, Professor Shriman, for your wonderful talk. I will again request Professor Debashish Kole to take over the proceedings.
Thank you, Professor Chakrabarty, for your wonderful and immensely informative talk. We can request the audience to come up with questions. So, students, if there are any questions. So,
Sir.
Yes.
Sir, hello sir.
Yes.
It was a very inspiring talk. Sir, I just have one question. That is, as you had mentioned about the lateral flow assay. So there you said that you would prefer like carbon dots for the detection line over gold nanoparticles or like something else. So why is that? Like, is there a specific reason for that?
The specific reason is that if you have a tiny amount, that is the concentration is low, the gold nanoparticle based conjugation may not give a sufficient signal in the test line.
So it is more sensitive.
More sensitive in a way that with a minute concentration, if that antigen antibody binding takes place, even with low frequency, that will emit the signal. The emission of the signal will not be missed because the carbon dot based emission is highly sensitive.
Thank you, sir.
Hello, sir. Thank you for your very inspiring talk. I have one question. I'm coming from a data science or mathematics background, so whenever you are doing the image analysis on all those things, so you're using your mobile capture images.
Two types of images what we do. One is that mobile capture, but that commonly we do not use because it requires a lot of optical filtering and all. Normally what we have is a device integrated camera. So, and it could be a mobile camera also, but it is almost integrated with the device in a way that the camera focuses on a particular spot where you have a LED illuminating with particular illumination power, which comes from the microcontroller within the system.
So any images taken from any mobile camera would not be
you can definitely come up with a result, but the medical world, the result needs accuracy.
Right. That was my question actually. Yeah. Thank you.
So if there are no further questions, then we can conclude this session. We sincerely thank Professor Chakrabarty for his engaging address and generous interaction with our audience and the students.
Sir, we have one question.
Oh, there are? Then we can do it after the session maybe? After, we can do it.
Okay.
Yes. So we move to the last part of the session. So now I request Professor Anirban Banerjee to kindly come to the stage and conduct the next session. Anirban.
Thank you, Professor Kole. Now, in the next session, we'll distribute the prize for C.N.R. Rao Education Foundation Award. So this C.N.R. Rao Education Foundation Award, they award a certificate and prize money 5,000 rupees to a student securing highest SGPA during the first 5 years BSMS dual degree program. It is given for both first and the second semester of the first year BSMS program. It is our great privilege to have with us our distinguished personality, Padma Shri Professor Narayan Chakravarti, kindly bestow the prestigious C.N.R. Rao prizes to our student. It gives me immense pleasure to formally introduce our special guest, Professor Narayan Chakravarti, a multi-faced personality. He received Padma Shri Award in 2024. He is widely known for his work in arsenic toxicity. Besides having a successful career spanning academics, research, and administration, he is also a well-known author, social worker, and columnist for daily newspapers and reputable journals. Professor Chakravarti earned his PhD in analytical chemistry from Jadavpur University in 1987. He began his teaching and research career in 1981 at government colleges in West Bengal and retired as head of the Department of Chemistry at Maulana Azad College, Kolkata in 2006. Post-retirement, he also worked as a visiting professor at postgraduate level at various institutions. Professor Chakravarti was a consultant and director at the West Bengal Biotech Development Corporation under the Department of Biotechnology, Government of West Bengal. He was a member of various technical committees of state government's biotechnology department. His research focused on the remediation and treatment of arsenic toxicity. He is a fellow of regenerative medicines and translational science from West Bengal University of Health Sciences. He is a life fellow of the Indian Chemical Society and was a member of American College of Nutrition. He has various research publications in multiple journals related to sanitary engineering, improvement of complexing agents, etc. Professor Chakravarti is the sole editor of a globally acclaimed book, Arsenic Toxicity, Presentation and Treatment. Beyond his research activity, he has always been actively involved in various UNICEF and CEPHO and Government of India program as a resource person and keynote speaker. Recently, he authored 2 Bengali books. One is Koronar Otimari Iti Kotha, and another is Dharma Shikha and Rajniti. This book captures his viewpoint on contemporary agendas in West Bengal and Bharat related to religion, education, and politics. As an author, his creative intellectual work have been widely appreciated. Now, to present the C.N.R. Rao Education Foundation Award, I request our special guest, Padma Shri Professor Narayan Chakravarti to kindly come on the middle of the stage. And I also request him to say a few words to our audience. Sir, please, you may use that podium.
Thank you. I'm grateful to Professor Sunil Khade, director of these institutes, my younger brothers, Devashish Kole and Professor Shuman Chakraborty, director of IIT Kharagpur, and of course, Swami Attopriyanandaji. You have heard serious lectures. The first one, philosophy of science, and the second one, integration of science and technology. Maybe whatever Professor Chakraborty tried to tell in a simple way, in a nutshell, that the science knowledge is the drinking water kept in a kolshi pitcher, which is not drinkable. The process of its drinking, that is the beneficial part of its applications to the society, is the technology. And he being a technologist, whatever he expressed, that is the biotechnology. Science is the question, inquisitiveness, to know the unknowns. But a sannyasi, if he knows so many things of this society and keeps it into himself, it is no way helpful for the society. Thakur, Ramakrishna, whatever he did, a very simple man in a very simple way, he tried to instill his knowledge, his idea, to ameliorate the social conditions of the time. That is the technology. Well, from any lecture, we can find so many incompleteness. I'm not going to that. But the one thing is certain, that on this very science day, if you go through about the discovery of Professor C.V. Raman, you can find that he built the instrument himself in ISES. But this present building was not there. It was in a rented house at Beaubazar Street. Afterwards, it came to this place when Mahendralal Sarkar came. That is a different story. Anyway, this, if you are to study science, then this inquisitiveness, what the previous speakers told, is supposed to be the precondition. And science is not giving any success to you and the society unless and until it is transformed for the, translated for the society. And that is the technology. So science may be the initiation of knowledge, the father, and the child is brought up by mother, the technologist. So father and mother together makes the child the benefit to the society, and science and technology are the inseparable part. If science is the bank, then the economic development, economic business, and all economic activities are the technologies. Thank you for giving me the chance to hear me. Now, about me, something was told. It is not translation, it is the basic, what is called stem cell technology, that is the translational science. So, that is a pure science subject leading to transformation to the society as translational science, and in this field, Dr. Shinya Yamanaka got Nobel Prize in IPC cell line determination, which has been benefited for so many, for the treatment of so many diseases in future. And the Nobel Prize was given to him in 1912 in this field, in the physiological science. So, the, say, clinicians, they are the technologists. Without the clinicians, all the discovery of this medical science would be useless. Since this is the process of transformation from science to technological benefits, and that is the part of your journey. When I started, me, Professor Shuman Chakraborty have one thing common. Of course, the difference in years. I was a student of Jadavpur University in basic science, and he was a student of Jadavpur University in engineering, mechanical engineering. So these are the basic differences. But the work in medical science, medical technology, keeps to us together for the benefit of the society. So I will ask you to be successful in life. You make science as a choice, and how you can go to the society for their benefits. If you can succeed, you are a successful, otherwise you are a failure. Anyway, thank you.
So thank you, Professor Chakraborty, for your nice words. And now there are 3 recipients for the C.N.R. Rao Education Foundation Prize in the first year, second semester in the academic session 2024-2025, who have secured the highest SGPA in the second semester examination. The first C.N.R. Rao Education Foundation Prize is being awarded to Mr. Kaushik Shanta Kumar, 24 MS 103, for securing the highest marks in the second semester of 5 years BSMS dual degree program in the academic session 2024-2025. I request Kaushik . A huge round of applause for him, please. Now our next award goes to Mr. Aryan Mitra, 24 MS 172, for securing the highest marks in the second semester of the 5-year BSMS dual degree program in the academic session 2024-2025. A big round of applause for him, please. Well done, congratulations. It is now time to call upon our next awardee of the day, and it goes to Mr. Arnav Vikrant Thorat, 24 MS 210, for securing the highest marks in the second semester of 5 years BSML dual degree program in the academic session 2024-2025. Congratulations, Arnav. The recipient for the C.N.R. Rao Education Foundation Prize in the first semester in the academic session 2025-2026, who has secured the highest SGP in the first semester examination is Mr. Salagare Aditya Amit, 25 MS 150. Please put your hands together for the last awardee of the day. So thank you very much, Professor Chakravarti. Now, with that, we come to a conclusion of today's program. On behalf of ISAR Kolkata, we extend our heartfelt gratitude to our Director, Professor Sunil Kumar Khare, and our Chief Guest, Professor Suman Chakravarti, our Guest of Honor, Swami Attopriyanandaji, and our special guest, Padma Shri Professor Narayan Chakravarti, for graciously accepting our invitation and enriching this celebration with their presence and wisdom. We also extend our sincere thanks to our audience, participating the schools and the college students and their teachers present here today. We hope that today's deliberations have further kindled your curiosity and strengthened your resolve to pursue science with passion and integrity. The exhibitions are now open, and you are welcome to visit the exhibition outside of this hall. We also thank all of our ISAR Kolkata family members for their support and help in organizing this grand event. So thank you all for being part of this celebration. Thank you.
Thank you, everybody.